Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening, but they fought with expert timing. There were funky Chinamen from funky Chinatown. They were chopping them up, they were chopping them down. It's an ancient Chinese art, and everybody knew their part. From a fainting to a slip, and a kicking from the hip. Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening. Yeah, but they fought with expert timing. There was Funky Billy Chin and Little Sammy Chung. He said, "Here comes the big boss. Let's get it on." We took the ball and made a stand. Started swaying with the hand. Sudden motion made me skip. Now we're into a brand new trip. Everybody was kung fu fighting. Those kids were fast as lightning. In fact, it was a little bit frightening, but they did it with expert timing.
Hello Professor, I hope you liked our introduction video. I'm Gopika and I would be telling you about our task board and the burn down chart for Sprint 1. As you can see here, we started with the Scrum exercise and every member in the team is assigned a specific task. We then spent time for learning and exploring the features of Greenfoot, and then we worked on getting familiar with the Connect features. The next thing we did was implementing the system architecture. Coming to the final part, which we are left with, is the video preparation. The workflows in different weeks can be seen here. How was the work going in the first week, and this is in the second week. Similarly, you can see how the work was going on in the third and fourth weeks. This is our entire task board for Sprint 1. Now, talking about how much time each member in the team has worked for the Sprint 1, you can see it here. Every member in the team spent 10 hours per week. So, in total, our team has spent 240 hours for Sprint 1. And moving on with the burn down chart, here is our burn down chart. You can see that we have finished the task on time and as per the schedule. Now, I would like to hand over to my teammate Ashish.
Hello everyone, this is Ashish from Team 11 and I'm going to show you a brief demonstration of the implementation of background as well as the in-world sound. So first of all, I'm going to run the game. Okay, as you can see, the background sound has started, and now I'm going to show the moment that the actor is going to be used in the game. I'm pressing the right key right now, and you can see the background appears to be moving towards the left. When I press the left key, you can see the background appears to be moving towards the right. Now, in actuality, this is not the case. What we've done is we have used the illusion of transition by using the recursive background, which is making it appear much more good looking, and basically enhancing the feel of the game. So another thing that I've implemented is the jump sound that is going to be used by this actor every time it jumps. Every time a user presses the space button, as you can see, there's a sound. There's a jump sound you can see, which I've implemented in this game. Alright. So the rest of the portion will be explained by Mr. Pratik Inamdar.
Hello everyone, my name is Pratik, and as my teammate Ashish explained about the environment, so the next thing that comes up to the mind is the other actors which will be playing their role in the given environment. So yes, my job was to get familiar with the actors that will be using into the game, and the introduction of the actors or adding the actors into the game. So the three actors which we'll be using in the game is the tiger, which will be chasing the panda which will be getting like which has to save its life from the actor, and there will be fruits which will be present to increase the life of the panda. So for this we have to create a panda class, a tiger class, and a fruit class, and we also need to create an object of those actors into the panda world. So here we have instantiated the three objects of the three uh, classes, that is panda, tiger, and fruit respectively, and we also need to add them to the panda world. So basically this is the function which is used to add a particular object into the world. So this takes three parameters. The first one is the object that is required to be added. The second and third parameters are the x and y coordinates which are to be added, and that, as you can see over here, the tiger, we have put it behind the panda, so the width is less than that of the panda. Okay, so basically about the background, so when the panda moves forward, the background has to move backward. So it's actually the background moving and not the panda, so this is the code for that. So the, the left is to move the background to the left, and right is to move the background to the right. And the fruits, we are going to place the fruits randomly at random position, and for that we have used the random leaves function. Herein we will be taking we'll be using a get random number function, which will take the get width function as a parameter, which will generate the width, and that will be sent as a parameter into the x and y coordinates, and it will take up the object as the fruit, and then a random object will be generated and placed on the screen using this. So that would be all, and now the panda movements will be explained by my teammate Chaitanya. Thank you.
Hello everyone, my name is Chaitanya Teja, and basically in sprint one, I had to deal with the movement of the actors and how their actions can progress in the game. So so as you can see, the panda actually is moves in a horizontal direction, and the panda can also jump whenever it faces some obstacles. So and yeah, so that the jumping of panda is done by using the spacebar key. So so the method which says green foot is key down space is actually the functionality of the jump that was used for the panda. And also you can see that there is a uh, dy variable which specifies the amount of jump that it takes when the spacebar is pressed. Uh, I'll show a demonstration of it. Yeah, so the panda moves in the forward direction, and yeah, so if you click on the space bar, but if you press the space button, it jumps once, and then yeah, you can have two jumps as well. So there is a functionality for that as too. uh, yeah, and there are some images that we have stored for panda, uh, like you can see here, it's 1.png, 7.png, left lower.png. So these are the images that should change accordingly to the direction of the panda. Like lu means left and upper, when it's in air. So yeah, like this is in the forward direction, and as soon as it moves back, you can see that the image has been changed. So that's the image that's the change of image that has been shown in this code. So yeah, so that was my part, like moving the actors and all. And the next part would be explained by Amit. So thank you.
Hi all, I am Shruti. My task was to integrate Kinect with Greenfoot and implement a program that demonstrates gesture recognition, namely raising a hand to make a character jump. For this, I first installed OpenNI, which is an open source library for gesture recognition, OpenNI Lite, which contains JNI wrappers for all OpenNI methods, and Kinect OpenNI drivers. Then I installed Greenfoot Kinect Server, which provides a bridge between OpenNI and Greenfoot. The Greenfoot project interacts with Kinect using the Kinect client class. The Kinect client class retrieves the skeleton tracking information from OpenNI using the user data class. We have a Kinect World class that extends the Greenfoot World class and instantiates the Kinect client. The world class for our game Panda World is used to instantiate the game character and implement the gestures. To detect whether a user has raised his hand, we check the joint data for all users to see if the y coordinate of the hand is less than the y coordinate of the head. Also, we do not want the character to keep on jumping in case the user keeps his hand raised. Hence, if the hand is raised for more than 100 milliseconds, we turn the left hand raised variable to false. So let's look at the demo. You can see my skeleton being recognized on the screen. When I raise my hand above my head, Panda jumps. And also if I keep it raised for a longer time, it doesn't keep on jumping.